Magandang umaga sa inyong lahat. Good morning, everyone. I'm finally back in the Philippines, feeling somewhat refreshed after a vacation in Japan. Today I want to talk about UEFI and malware specific to it. Please note that, like the previous video on this channel, this is basically an opinion piece because I went ahead and let myself get spun up again, so take this with a large grain of salt. I am too soon off vacation for getting spun up like this, so it's my bad, but, well, did have a good time in Japan. Tokyo, we stayed at for a few days, and we took the bullet train to Osaka. That was an interesting experience. It's much cooler in Japan than it is here in the Philippines. Last time I was in Japan for any length of time outside of an airport was 1977. So in 2024, things have changed a bit. It's much brighter, a lot more big lights, a lot more signs, a lot more people, a lot more crowded, a lot of less traditional stuff than I remember before, but that was a while ago. Did get to see the cherry blossoms though, so that was nice. Seeing them someplace other than in Washington, D.C. Did some shopping. Well, I held bags, my wife shopped. Visited some of the less we visited some touristy spots and some of the less touristy spots, and we ate in some out-of-the-way restaurants off the beaten path, which had some good food, But enough about me and my vacation. You're all here to learn about UEFI and malware, so let's get to this, okay? This all started about a month ago, even before I went on vacation. I started seeing an increasing number of videos and articles and other items coming across my computer on UEFI-based malware, showing up for, various logarithms, whatever. I'm not quite sure how it got triggered, but I've been seeing them. And while some of these articles and videos were fairly informative, quite a number of them were full of hype, promoting a certain level of fear. Now, from what I have reviewed and studied and researched, most of this is over-the-top fear-mongering. UEFI attacks have been around ever since there has been a UEFI. Again, Unified Extensive Firmware Interface. It's the legacy BIOS replacement. I don't mean to shortchange any of these things I have watched or read, but I feel a little context is in order here. And there will always be bad actors out there trying to take advantage one way or another, so it's nothing new. Interestingly, there have been surprisingly few actual documented UEFI attacks out there in the user space, as compared to other types of viruses and malware. In many cases, when one actually reads, we find out that a lot of articles hype a vulnerability identified in some lab or think tank somewhere rather than an actual attack. My suggestion is just read the context and don't get too paranoid over the hyped up headlines, as the article contents don't necessarily follow from what's in the headline. To that end, I want to discuss the Unified Extensive Firmware Interface. That's such a mouthful. Wow, just call it UEFI, the BIOS replacement. I want to discuss the system from a somewhat abstract level, then discuss some of the basic malware attacks that have been out there. I also want to stress that, like any other malware, the best way to avoid it is common sense. Don't engage in risky behavior while you're online, and know what programs you're running, and do regular backups of your data. Incidentally, I'm trying a bit of a new format here on this video. We'll see how it works out. If you got any comments about it, let me know. This is going to be a little bit different than some of my other videos. So, onward. To actually understand the nature of the UEFI malware threat, we need to understand a little about how UEFI and how it works and how our computer boots. When the computer is first turned on, the CPU, there it is programmed at the factory to go to a specific address on the system board firmware. Where it starts executing code, it finds there. This code is generally low-level assembly type stuff and gets the motherboard up and running. It's got several stages it goes through, and this is all part of the UEFI interface. First one's called SEC, or security, is the first stage. It gets the CPU up and running because when you start your computer, your CPU is basically in a reset mode. SEC is short for security. I think I said that. Trusted embedded non-writable ROM information is used to validate the writable firmware. In theory, one would have to replace the ICs on the system board to get around this. This is very low-level stuff, so there is only so much that it can be done. But resources are going to be needed to continue the boot process, so during this phase, the CPU is powered up in protected mode, along with the memory. In the PEI, or pre-UEFI initialization phase, is the next. The purpose of this phase is to set up a small runtime environment when basic services and hardware can be run and communicate with each other. This is all basically still happening on your system board. This is followed up by the driver execution environment, or DXE, built on what PEI started, initializing higher level platform functions. In this phase, the EFI configuration table is also initialized. This will determine in what order various bootloaders get checked. Some form of post or power on self-test to validate all system board hardware and initialization should happen around this point. Once this is all finished, we go into the boot device section, or BDS, and this tries to run the bootloaders previously identified in the set order. Inactive bootloaders will be skipped. The first active bootloader on its list will be the one that's run. Note the firmware is stored in some type of flash memory. Generally, it is treated as read-only, but it can be written to if needed. This is how the system board manufacturers do BIOS firmware updates, or UEFI firmware updates. And there's a few other things, like how the boot order also gets stored. When your operating system bootloader installed, it should have added a pointer and set its boot order in the UEFI firmware, aka writing to the firmware. So when the system boots, it checks these pointers in order until it finds the one with the bootloader stored on an EFI partition, also called EFI system partition, or ESD, which it then runs. Note that the ESD is not where your operating system resides. It's a separate partition. You're probably not going to see it if you're running like Windows, so it's there. The bootloader is going to do its own checks as well as start the OS that created it. Once the OS boots, operating system OS, once it boots, it will start running its auto start. This is where several applications, including your antivirus, most likely start for the first time. Well into the boot process at this point. All right, let's settle one thing right here. UEFI is not a program or an application of any sort, it's a standard. BIOS and system board manufacturers build their software to this standard, which has some interesting ramifications. Specifically for our discussion, if a module or code block can take correct inputs from another one and provide correct outputs, UEFI does not care what else that code does. However, to get code into the firmware, one merely has to look at how the manufacturer does a BIOS update. I was surprised to find how many BIOS updates could actually be opened with programs like 7-zip and various parse extracted and examined. This makes it somewhat easy to hack the code from a BIOS update and repackage it, which can kind of explain how these attacks go. The big issue for the hacker is getting you to run on your computer the new code they've generated from this. They either need to have physical access, remote access, or get you to run the code. That would be like a phishing attack. There are basically two places malicious UEFI code likes to hide, where it can be run before your antivirus, which is run over here, as opposed to over here, where your computer starts up. So this code's in the UEFI, so it can run before the antivirus starts. One place is in the firmware and the motherboard, and the other is in the ESD partition on your storage drive. Again, both before your antivirus runs. I want to note that my research shows there are a limited number of UEFI malware hacks, and these are fairly sophisticated, meaning a hacker living in a parent's basement is unlikely to create them. The code seems to come from well-organized and sophisticated groups, so it's most likely to be targeted at governments or large businesses or the like. Too much effort to attack a normal user. This does not mean there are no worries, however. Once the code is out there, less skilled individuals who get their hands on it will no doubt try to get other targets. However, I suspect most groups will not give their code out until or after some point at which it's compromised in some fashion. I mean, this stuff takes a while to generate, and they probably don't want to lose any advantage they get from it with their targets by some would-be hacker compromising their code. So yeah, I don't think they're going to let it out unless it's compromised in some fashion. The reason this type of infection is hard to deal with is twofold. First, as we have seen, and we will see in some examples, it runs during UEFI startup as early as the DXE phase, and any antivirus that you have does not run until after your OS boots. Additionally, network surfaces can be accessed at this point, again, before your OS boots, once the hardware is, your UEFI has a hardware up and running, because UEFI is basically a mini operating system. So the network can be accessed, and the malware, if it needs to, can download additional modules, again, before your antivirus starts up. Wiping your primary operating system partition will have little effect if the code is in the ESP, and even removing your ESP may not have any effect if the code is actually in the firmware. More than likely, it will require a firmware update from your manufacturer delivered on some form of unwritable or non-writable media to take care of issues like this. Technically, one could try and access the firmware with a hex editor or via JTAG or a similar process, but this is more than likely to brick your system board than actually get rid of the malware. So I don't recommend trying that. Okay, let's talk about a few UEFI malware examples. One was called Moon Bounce. Well, I guess it is called Moon Bounce. Some think this is a UEFI boot rootkit. Might be the work of the APT41 group. It was discovered by Kaspersky Labs. When it gets into your UEFI, it allows the hacker to gain control of the boot sequence, adding malicious code to the firmware embedded in the firmware. It works strictly in memory, meaning all traces disappear on a reset. The primary purpose of Moon Bounce is to allow the undetected insertion of other malware packages. Another example is Black Lotus. This one was designed for Windows. This UEFI rootkit incorporates a built-in secure boot bypass as well as being able to disable BitLocker in some cases. Note that Microsoft has since patched this vulnerability. Cosmic Strand is another one, an interesting one at that. It was found embedded in the firmware of system board from two manufacturers. This means you bought your board, it already had the malware in it. The question here is, how did the UEFI rootkit make it into the manufacturer's UEFI image that they were using to flash the system boards? Interesting question. Like I say, these are usually well orchestrated attacks, not some random user or some random hacker doing it. Mosaic regression, this one gets installed via phishing ploys. It writes malware executable file and runs it through a Windows auto start. That is to say, through a phishing ploy, it gets installed in your UEFI, and when you run your UEFI, it installs a malware executable file that is started by Windows auto start, usually before your antivirus. Another example is something called logo fail. This was not actually a UEFI rootkit or virus of any sort. Instead, this is a vulnerability that was identified in the UEFI graphics library. It allows bad actors to hide code inside a logo, like most manufacturers display when you boot your computer, that will run during the DXE phase. Again, this was not an actual hack attempt, this was a vulnerability, which goes back to why you need to read the articles and not just go by the headlines. So what to do? Well, first off, can help yourself by not getting infected in the first place. UEFI rootkits are installed in one of three ways. First is the direct physical access, then the remote access, and lastly by some malicious program you downloaded from the internet. In certain cases like Cosmic Strand, where the vendor got hacked, there's nothing to do. It's up to the vendor in this case to fix the problem. But in most cases, standard security measures should be enough to keep yourself from getting infected. Be careful what you download and what you allow to run on your computer. Be careful who has access to your computer. And be very, very careful about who you give remote access. I mean, we've all probably been to some of these troubleshooting sites, and some of them are legitimate that want remote access to help you troubleshoot your computer or something. I mean, they're out there and we've all probably seen them, but like I say, be very careful who you give remote access to. And one countermeasure I am going to harp on here, it's one that I'm guilty myself of not taking seriously because you actually have to do stuff. And a lot of very conscious people don't do this. Keep your BIOS firmware updated. Check the manufacturer's website periodically for these updates, as they will not be installed automatically by your operating system. Again, I stress, this is something most people, or a lot of people, like I say, I've been guilty of this, don't do, is periodically go to the manufacturer's website and look for a BIOS update. But you should. Okay, that's it. That's my whole spiel. That's my whole rant. Your odds of getting affected by UEFI malware are probably less than other forms of malware. I mean, it's far less prevalent. But like any other computer malware, be aware and employ proper safeguards to protect yourself. As I said, I'm trying some new stuff with this video, so give me your opinions on how this works as opposed to using a Impress slide, is doing things on screen. Again, just trying new stuff, learning new stuff. So I got to finish up my next video. I was on doing Apache LAMP server, so I'm going to actually, my next video, be installing some web applications. So hopefully you'll stay around and watch that one. And we'll see you all then.